Hello everyone and welcome again. So far we've covered everything related to the RBD simulation. The last part we want to add is the debris system, and I wanted to show my workflow that I use that is very stable and solves a lot of issues. Now there's two approaches for creating debris, and by debris I mean the actual rocks that are emitted after something a big rock hits something, or just a crack crumbling. Anything like that would cause debris to fall, and these would be made of actual geometry, not particles. And to do that, there's two ways. You could either use particles, emit particles, give them a spin attribute, an angular velocity, so that they would spin, and then you instance and copy geometry to that. But the problem with this is that you have to do a lot of math and calculation to get the proper rotation, to get the proper physical behavior, and getting particles to interact with this RBD system can be very challenging, because the pop solver and bullets, they don't work really well. So if you use this mesh as it is, the dop solver is going to have to rasterize that into a volume and use it for volume collision. Otherwise you're not going to get actual correct result. If we wanted to provide the pop solver with decent results, we have to create our own volume, which will be really slow and won't capture all the details. And the only thing that you would save is probably some sim time, but it's not either guaranteed, because you will have a huge amount of collision and you're gonna be spending way more time tweaking it. So that's not how I do it. I do another rigid body simulation using bullets, and over the years bullet has gotten so fast that you can sim, like we saw with the upres workflow, we can sim hundreds of thousands of pieces in a couple of hours, especially when you don't have constraints and when you don't have a geometry available for a long period of time. You can get very, very fast sims, and my workflow utilizes the RBD solver to create the debris as a separate sim. And I'm gonna show my cache and briefly talk about the rendering workflow and some of the drawbacks. So this is debris, and it's getting emitted from the cracks of the geometry. You see, those are the main areas that splits first. Okay, I'm emitting a lot more than what it should be, but I wanted to do that. So as I play through, you will see that we're getting debris everywhere. Let's go. And this is done using rigid body solver and emitting debris whenever something meets certain conditions. And the conditions would be either two pieces have separated, or something hit something else with a huge force, and you want to only emit one time. You don't want to continuously emit, or you want to emit for a very short period of time, so that when this condition happens, it only pops particles points, and then those will be used as the source for the rigid body. So that's how it looks. This is the final one. And there's a lot of stuff underneath, but it wasn't too bad to sim. I think it took about 1 hour as well for this. And because it's very small, it's hard to tell what the collision is doing. So what I do is I use the box approximation instead of convex shape, and that would make it sim much faster, and it would still give us that behavior of spinning and hitting and rotating and doing everything that it needs, in friction, all that stuff. And actually towards the end there is some really cool bits, like here for example, and this is visible in the main render. You will see debris sitting on top of this and then sliding and crossing over the fire, and the fire is behind them illuminating, and looks really nice. Okay, so how do we do this? Well, the first thing is I'm gonna try to illustrate this. I'm gonna create a grid. I'm gonna scatter some points. gather 100 points, and I'm gonna animate them. I'm gonna copy geometry to it. I'm gonna use a box. And I'm gonna scale the box. I'm gonna give them a velocity that points upwards. So v equals set of 0, 1, 0. I'm going to use an RBD bullet solver. And I'm going to make sure this is packed geometry. So create packed geometry. I'm going to feed this in. Now with this, with the RBD bullet solver, it supports this by default now. Before, we'd have to do something else. We'd have to do it in DOPS, and I will show how that can be done. But now all we have to do is emit RBD, and then if we hit play, it's going to continuously emit. And they added it for this purpose because a lot of users were doing this. So let's increase the velocity, and let's put it here first. Let's hit play. Okay, let's increase the velocity to 100. So that's emitting all these boxes every frame. And 100 is probably too much. Let's try 5. Let's try 15. And I'm going to add a ground for the collision. And let's move this up. Or this. Okay. Let's hit play. So we have RBD pieces getting emitted, and they're never going to stop. And you see they're interacting, and it's super fast. So that's how we're going to do it. We're going to find an interesting emitter that we could use, and we're going to use QLib for that. They have, it's a 3D it's a library for Houdini it's a library of OTLs for Houdini, and I use it quite a lot. They have a lot of cool features. Let's play this again. Yeah, let's see how many pieces we have. So 5,000 almost, and it's working pretty well. So we're going to use QLib, which is a library of OTLs for Houdini. It is maintained by a couple of guys that works at Weta, I believe, or a few other places, and they have a very fast RBD sourcing tool that we could use. It's much better than the debris source, and we'll talk about it in the next video. Thank you guys for watching, and see you in a bit.